All right, here we go. So, Java basic terms. Okay, so we're going to go over some basic terms so that when we start programming, there are a few things that make sense. If you're an advanced programmer already, maybe some of this will be new to you. Maybe it won't. Okay, but no big deal. Okay, first thing that you need to understand, there are a couple of packages that the computer has that we need to be aware of. Okay, we've got something called the JRE, that's our Java Runtime Environment. That is what runs a Java program. It's what translates Java program into like something that can be executed. Okay, you need this in order to run anything that's Java. Okay, so like any program that you might have. Sometimes you see errors on your browser, and it'll be like, you need Java to play this program. Anybody seen that? Okay. That's what it needs. It needs a Java runtime environment. That is required just to run Java. So that has nothing to do with programming. That just means I need it to run a program that's written in Java. Okay? JDK is a Java development kit. Okay? What that does, it allows us to compile Java code. It allows us to take things that are written in Java and translate it into a program that can be executed in Java. Okay? In order to program in Java, type a program, compile it, and run it, you need a JDK and a JRE. Okay? It would be a really terrible way to program in Java, okay? Because you would be typing into like Notepad, and then you would save it as a .java file, and then you would compile it, and then you would run it, and it would be miserable, and you wouldn't be happy, and you wouldn't like it. Okay, but you could do it, and that's something that you need to understand. If you wanted to, you could program with just a JDK and a JRE. Okay? We use something called an IDE, which is an integrated development environment, and the one that we use on our computer systems here is BlueJ. Okay, it's free, it's great, it's super basic. Okay, it's not advanced. Some of you have programmed in other IDEs before, right? Have you? Like some of you have used IntelliJ or you've used other things, and that's fine. And if you're comfortable with that and you want to do all of your assignments in that IDE, totally fine. I'm just not going to be able to help you because I'm not super familiar with a lot of the other IDEs. Okay. I can help you with Java code, but I'm not going to help you with. I'm not going to be able to help you with like how that IDE works. Okay, so the IDEs are what make it nice. It makes it pretty. It color codes certain keywords. It automatically indents certain things. It makes it easier for us to read. Okay, but it's not required. Like you need to understand that you do not need an IDE in order to write a program. Okay, ours is BlueJ. If you want to put BlueJ on your computer at home, again, I told you it was free. Okay, there are directions for how to do it. I shared 2 documents with you on Google Classroom today. Okay, one of those is a lot longer, and it starts with directions for how to put it on your computer at home. If you want to, you can. If you don't want to, that's fine. If you decide later on in the year that you do want to, just know that the directions are on that document, and you can go back to them and use it. Okay? Are we good? We're following. So what do we need to program in Java? A JRE and a JDK. What makes programming really nice? Great. Okay. Okay. So the Java programming language is what's called an object-oriented programming language. Okay, that means that in its purest form, in the way that like fantastic programmers would use it, everything is put into an object. And so let's say I wanted to write a program for like making a cake, hypothetically. I would have an object that is flour, and I would have an object that's egg, and I would have an object that's like the blender, and I would have an object that are all of the different components that I would need. And then when I wanted to make the cake itself, I would have a method inside one of those that says, okay, mix all of these objects together, and that's how it would be broken down. Okay, it's kind of weird. We're not going to use Java as an object-oriented programming language right now. Beginning of the school year, we're going to use Java as we're just going to learn how to program, like the basics of programming in Java right now. When we get into our programming, when we make games next semester, okay, when we make games next semester, get excited. We will use Java more like an object-oriented programming language. We will have an object that is Mario, an object that's the Goomba, an object that's the block. an object that's a store. Okay, so we'll have objects for every single thing that we create, and those objects will then interact with each other. Okay. For now, we use classes as containers for our code. Okay, like everything that we type into our program are going to be in one class, and that's it. Everything that we use, all of the code that we type, is going to be inside of our class. Okay, there's one other strange little thing that we might want to know. So there are two keywords there. We've got class and we've got objects. Okay, so a class is like the blueprint, right? So maybe like in a neighborhood, we have blueprints for houses. Okay, and the construction person, company, right, they know that like this is going to be type A house, this is going to be type B house, this is type C house, and then it repeats or something, hypothetically. Okay, the blueprint for that house, again, the blueprint is the class. So the class would describe like how many bathrooms it has, how many windows it has, where they're located, where the kitchen is, all of those types of things. But the object is like once the house is actually built, following that blueprint, that's an object. Does that make sense? So we have objects, and they like describe. Or sorry, we have classes, and they describe what our objects are going to look like. And then when we run code, we create objects that meet the criteria of those classes that we'll build. Okay, it's kind of weird. We'll break it down later. Okay, and we'll practice. Like it's going to be something that we keep like we'll reiterate throughout the year. Okay, but understand that there's a difference between a class and an object. Okay, here we go. This we will type in just a minute. But first I want to give you an overview of what we're going to learn in this unit. Okay, in this unit for Java, we're going to learn printing text to the terminal. We're going to learn what the terminal is shortly. Okay, we're going to learn the difference between a print line and a print. We'll do that like that's today. We'll take care of it. Okay. We're also going to learn how to do generating random numbers. We're going to learn if statements, while loops, order of operations for math computations, and we're going to learn about different data types. Okay? It's okay if none of these don't make sense to you right now, but at the end of this unit, before your test, that's September 28th, before your test, okay, you're going to be able to look at this slide and be like, oh yeah, I know what that is. Oh yeah, I know what that is. Oh yeah, I know what that is. Okay? So right now, this is where we're going for this unit. Are we good so far? Okay, so you should have checked on your desktop last week to see if you have BlueJ. So at this point, I want you to find BlueJ on your computer. Okay, so you find BlueJ and open it. Yours should be totally blank. You shouldn't have anything. Press yes to the warning. Okay, you should have nothing there. If you do have something there, you should close it because I'm going to show you how I want you to name things and where I want them to go. Okay, so press project, new project. And then on the left, I want you to go to this PC, and I want you to find your student ID number. This is your personal drive. Okay, this stuff goes with you. So if you logged into a different computer, it would be there. Okay, and that's why I want you to save everything there. Because let's say the kid in the next class spilled coffee all over the computer, then you wouldn't have your stuff, and that would be mean, right? Okay, so always save it to your personal drive so that no matter what computer you log into, you have it. This is also so if you went to Mr. Monroe's from after school for tutoring, it would be there. Okay, so you're double clicking on that, and then. Okay, then right here, you're going to save it. Your folder name, I want you to put Java Unit 1. Okay, it's not going to let me save it with the same name. I already have one. So I'm going to put Java Unit 1. Third period. So you're going to create, and now it's going to pop up, and now you have like a little piece of notebook paper, and that's the only thing that you have in the background. What? So are you into this? So project. And then do All right.
I won't give you pictures.
So we should all have a new project open. You should have that piece of paper on the left. Or never use that piece of paper, just ignore it, it doesn't matter. What is going on? You're just like looking in your mouse later. Maybe not a great idea. Okay.
Why you were a genius.
So here we go. Now you're going to create what's called a new class. Each class, this is going to be what you actually submit to me. I think I missed a slide. Okay, this is going to be what you submit to me. So I always wanted to have your last name. So your last name first. You can do lowercase or all uppercase. It doesn't matter. But I want the first letter capitalized. It's a convention of computer programmers that we capitalize the name of classes. So your last name. Your last name, underscore, this program is called Hello World. Okay, you cannot have a space in the name of a class. You cannot have, you cannot start it with a number. It has to start with a letter. And the typical convention, Abraham, is that we would start with a capital letter for the name of the class. Okay. Okay.
This word sucks.
So after we do that, we press OK. And now you'll see that you have a little box that is named after what you just typed in. Okay? Okay, while you're finishing that up, okay, we didn't talk about this, right? Okay. So real quick, somehow this slide got skipped. When we take code, our code, we write it as, it's going to be a .java file. So that program that file that we just saved, we just created, that's going to save itself as a .java file. It's not compiled. It's in like human readable language. Like we could look at it, I could look at it, and we could kind of understand what it was, especially as we were training. And at the end of the school year, we should be able to look at it and totally understand what it's saying. Okay. This is called source code, and it's a .java type. So just like we have a .jpeg or .xls or a .doc, this is a .java. Okay. When we compile it, we send it through this magic thing called a compiler. Okay. If you continue to study computer science, you would one day learn what that does and how it works. Okay, it compiles it and it takes it and it turns it into what's called bytecode. And that's got a .class file type. Okay, so again, it's like you have XLS or .doc or .whatever. The .class is the bytecode. It's what the computer understands. Okay? So when you're submitting to me, am I a computer or am I a human? I'm a human, last time I checked. Okay, so I'm a human, which means I want the .java, not the .class. Cool? So when you submit me the .java. Okay? Good? Cool. Great. So. Okay. So you just made this. And this is what it looks like, right? It's got the // through it. That means it's not yet compiled. That means that right now we just have a .java saved, and it's not ready to run. Okay? So if we double click on it and we open it, we have a bunch of stuff going on in here that makes no sense, right?
Yes.
So this right here, you've got the /, the /, and then it ends with a /. This is a comment block. You remember in code.org where there, like later on you had an opportunity to put in a comment block that none of you probably used because it's like, why would you use that? You didn't make me comment it. I wouldn't do that. Okay, commenting in computer programming is super helpful because we can write. So like, let's say I wanted to write up here, this program prints out hello world. Sorry, my wireless mouse is not. This program prints hello world to the kernel. So basically, this chunk of code is, or this chunk of words is not code. This is like for you as a programmer to type something so that you remember what you were doing when you're writing code. Okay? So this is so, like, if you were gonna be out of town for like a week and you came back and the next day, like, you were like, I don't remember what I was doing. Like, this would have been good for you to have commented on some of your code. Okay? Or even just between like one day and the next. You don't need anything here right now, you can delete it. You don't ever really need any comments there. I'm not going to grade your comments, but they are helpful. Okay. The other way that you can comment is you can do 2 slashes, and that would just comment out like the rest of that line. So we'll find this super useful sometimes when you're programming and you just want to see if the program works without a particular line of code. You can comment it out, and then it's still there, so you don't have to like retype it all, but it's available to you. So the 2 slashes, that comments out just that single line. Okay, delete everything inside. So from public class, your last name underscore hello world, delete everything after it and everything before. You should only have 1 line on your computer. Delete everything. Delete the comments before it, delete everything after it. You should have 1 single line right now, and it should just say public class, your last name, underscore hello world.
Hello world. Here I am.
Okay. The first thing that you need to know, so this is a class. What did we say a class is when we were talking about it earlier?
It's
like a blueprint.
Blueprint.
And right now we're going to think of it as the container for our code. Like all of our code is going to reside within a class. Okay, so it's our container. Every time we create something like a class or a method, which we'll talk about in just a second, or an if statement or a while loop, we open and close curly brackets. Okay, curly brackets are next to the P on your keyboard. Okay, and the curly brackets tell the computer, they say start here for this class and end at that last curly bracket for the class. It's basically like your start mark and your end mark for that chunk of code. For that container, if you will. Okay. Inside of our curly brackets, we're going to create what's called a main method. Okay, we're going to do an entire unit later on talking about methods, but you do need to know that the main method is where all of our code starts. So when we're running code, it's going to start at the main method and like run through code sequentially. Okay. So right here, we're going to type public static void main. That's not main, that's main. Okay, and then I'm going to stop right there and I'll type the rest in just a second. Okay, these are all keywords and they mean important things. Okay, notice that they color themselves the same. Like public is purplish, right? Class up here is like bright red. Okay, static is also purple. Okay, this is a public method, meaning it's accessible throughout your entire program. Okay. Static is similar to that. It means that it's accessible throughout the whole program, but it's going to be more constant than like something else might be. Again, we will talk more about static later. Void is what our method is going to return. Okay, again, we do an entire unit on methods, so that's kind of like weird terminology. We'll get there. Okay, after this, we need to give our method some arguments. Okay, so we're going to open a parenthesis, a regular parenthesis. Just over the 9, and we're going to type string args, and then we're going to do an open close square bracket, and then we have to start closing. So we have to close our parenthesis, and then we're going to open a curly bracket and close a curly bracket. Okay, all sorts of weird parentheses and brackets going on. All right, so the name of our method is main. It's returning nothing. That's what it means for it to have the void. Okay. It's taking in a string array that's called args. We will talk about arrays, we'll talk about strings, we'll talk about methods. So if none of that makes sense, it's okay. But this is one of those things where like you have to press kind of the I believe button on this line of code, and we'll break it down in a couple of months once we're more able to.
That's not good. I know it's yellow, but it's like.
Mine's purple.
Okay, this string has to be capitalized. This is a data type. And it's saying it's the data type of this variable called args. The square brackets make it an array. Again, it's okay, don't worry about it right now. What you do need to know is that this is the main method and all code execution starts in the main method. And you need to know what this line looks like. You don't need to know what all the words mean, but you need to know it's public static void main, open parentheses, string args, or square bracket. Okay, so you need to know what it looks like. You need to know that it's the main method and that's where all of our code execution starts. But beyond that, you're okay. All right? The next thing we're going to do is we're going to print something out to the terminal. Okay, so we do this doing system out dot print. And we'll type hello world. This is a rite of passage for programmers. You have to do this in order to be a real programmer. You have to output hello world to the terminal and feel victorious at the end. Okay. Every line of code, if it's not a method or if or a loop, if it doesn't like have a curly bracket right after it, it needs a semicolon. If it does have a curly bracket or normally would have a curly bracket, it cannot have a semicolon. So it's either going to be a curly bracket or a semicolon at the end of every line. Okay, after you type this, you can go ahead and press compile in the top left corner. And then at the bottom of your window, you should see something that says, come on, mouse. Oh my gosh.
Oh, so screwed. I think
I want to make it color change.
At the very bottom, you should see something that says, class compiled, no syntax errors. Okay, and so right here, it says something other than class compiled, no syntax errors, then that means we have what's called a bug.
Yep.
So we need to debug. Anybody know where the term bug came from?
insects.
Actually, yes. So, you want to know where it came from? It came from back in the day. One of the very first computers was the ENIAC, right? And it was built during World War II. Okay, and you had all these super smart mathematicians who were trying to build computers to solve tons and tons of linear equations so they could calculate the trajectory of missiles, right? That's what they were trying to do. Okay? And it was open. Like, all of these connections were open, and there were wires that would plug into different places, and they would have to, like, move the wires depending on the different program that they wanted to write. Okay? So they're moving wires, right? And this huge, like, circuit board of stuff that's happening. All right? And then occasionally there would be a bug that would end up in this huge set of all these wires, and so they would physically have to debug the computer, take the bug out of the computer. Okay, that's where the term debug came from.
Oh, I thought you
Okay.
meant like a physical insect.
So, no, it was physical insect.
Like,
Oh, an actual insect.
Yeah, like an actual bug.
Yeah, okay, that's what
An actual bug was on this like huge circuit board of stuff, and they would have to take the bug off of the computer. Okay, so we still call it debugging today.
I told you, I knew it.
Okay, so if it does not say class compile no syntax errors,
Why does that say?
if it says print end of file while parsing, that means you are missing a curly bracket. Okay, one thing I need you to understand in this class, if you get an error, if it doesn't say class compile no syntax errors every single time, that is okay. It does not mean you're a bad programmer. It does not mean you're bad at this class. It just means you maybe aren't a good typer. Or it means you didn't pay attention to something. So it means that you need to go back and you need to look at what you did. Okay? So do not be that person who reads something here that isn't class compiled and you like bang your head on your desk. Okay? Like, it is not bad. It just means we have to readjust what we did. Okay? That's it. Are we good? Okay. So,
I said we're good.
all right. Do we all have class compiled no syntax errors?
No, I mean, yes.
Okay. So what I want you to do, I want you to go to that screen that we were on to start, where we opened the program from.
How do we go there?
It's still open in the background. So minimize the window that you're on. There you go. Okay. Right click on this box. And where it says void main string args, click that. Don't type anything in. Press OK.
Oh!
Crazy. Wow.
Congratulations.
We typed
You
all of
have
that.
typed your first program.
AI.
Oh, wait, what?
Yeah, so
Oh.
maybe you just you're missing a Charlie Brockers. Okay, so now we have Hello World. Congratulations, you're all officially programmers. Okay? Did anybody not get Hello World? Okay, a couple things that are going to be super, super helpful in this class. Do we know copy and paste?
Yes.
Do we know the short keys for it?
Control Alt Delete.
No, that's not
That's
right.
Just control.
Control C and Control V, those are your best friends. Okay, I'm going to introduce you to two more. Okay, you've got Control C, that's Control Copy. You've got Control V, that's Paste. Okay, Control X is Cut. So what cut does is it cuts it from where it is, so it takes it away, but then it's stored on the board, so like the clipboard or whatever, so you can paste it somewhere else. Okay, so if you wanted to move your piece of code somewhere else, that's Control X. Control Z is what? Undo. Okay, so they're all in a line. Control Z, Control X, Control C, Control V. They're super helpful. So, okay, so in your program right here, where it says system.out.print hello world, I want you to copy this line. So Control C and Control V. Control V. Copy it a few times. I don't care how many times you copy it. Copy it a few times. Put it into that so that it's printing hello world multiple times. Once you've done that, compile it and run it again and see what happens. Hey, is that what we think it's going to do? Do what we thought.
Hello, world.
What are you doing?
World, hello, world.
Hey, Connor. It says girls hello. Oh no, it's because
Control C
it's
is
just hello world. Girls.
V is paste. V copy, V paste.
Oh, it's because there's no space.
Yes.
Are you like watching that?
Who, me?
Dad?
Hello, hello.
Okay, so what happened? Did it happen, okay, in an ideal world, did it print out the way that we wanted it to print?
No.
Like the way that you would ideally have it had printed?
No.
Okay, so when we ran this, it prints all weird, right? Like it prints hello, space, world, but then the next hello is like immediately tacked onto the end of it, right? Kind of weird. Okay. One thing that you need to know is that as computer programmers, you are the smartest person in the room. Okay? The computer is as smart as you. I don't know, me probably. No, I'm just kidding. Okay, that's probably not a statement. Okay, so the computer is only as smart as the programmer who's telling it what to do. So this computer program did exactly what we told it to do. It printed hello world, however many times you copied and pasted it, but it didn't add a space after hello world, and it didn't add a line. Okay, so let's try adding a space, okay? One thing that we can do is, okay, so after hello world here, okay, I'm going to do this. There are multiple ways you can do this, but I'm going to add, physically, I'm going to add a space. So plus space. You could do it that way. And that's what we call concatenating strings. So we're actually merging strings together. Okay, you could do it that way. Or you could type a space right here. Okay, I want you to practice both. Okay, so see both.
On one bit.
And the last thing I want you to do on the third, so let's say I want you to have 4 like I have. On this last one, I want you to put LN after your print. So there's no dot, it's just LN after print. These are still print. This is print, print, print LN, and that's still print. Yes?
Can you do block backslash?
You can. But I don't know exactly, so that's gonna, the N's gonna be an NY, does it compile? Yeah, totally, you can totally do that. If you wanted to just tab it, you could do /T, that would tab it. What?
No, oh.
Okay, so when you run it,
Why are there 3 parentheses?
what?
Why are there 2 parentheses after the plus?
These are quotes,
That's what it is. Sorry.
because I'm physically adding a space,
Oh, plus and
plus, and then another string that is a space. Okay, so after we do that,
Oh, thanks for spoiling it, Wyatt.
where'd my terminal go? Okay, so here is the, okay, actually I didn't tell you guys to do this yet. So on the terminal options, you see how it says clear screen at method call? Mine's checked, yours probably isn't. If you check that, what happens is every time you run the method again, it's going to clear the terminal screen before. So yours probably says hello world altogether from the last time you ran it, and then it says it from this time that you ran it, and it doesn't separate it. But if you clear screen at method call, it'll just be the one method call on the terminal screen every time. Or you can just clear it manually. Okay, but this is what I got. I got hello world, and then I got a hello world, and then I got a hello world with an enter. So the first 2 do basically the same thing, right? So these first 2, they look the same. I've got hello world, and then I add a space. Then I've got hello world here, and I added a space. Both of them did the exact same thing, true? Okay, so I don't care what your preference is. You can do it either way, okay? But those both work. The next one, this is system.out.println, hello world. This is print line. Okay, so we added hello world right here, and then what did it do?
Yeah.
What did it do?
It went to the next one.
It went down to the next line. So what that's called the carriage return. So think like a typewriter. Typing. You press enter, and it's like ding, and the carriage physically returns to the beginning of the next line. That's what it is. It's returning to the next line, and it's going to print whatever you have there on that next line. But it goes after. So notice that it printed hello world, hello world, hello world, and then it typed enter, and it waited to print the next hello world.
Oh, can I right click it and go to the void names? Oh, did I add something by accident?
If you didn't compile it, that's not going to be there. So that'll only show up when it's not slashed. So you're good to run it.
Oh, wait, stop.
Okay, so that's one important thing, that print versus print line. So print, it just prints exactly what you tell it to print, and then it's waiting. The cursor is just waiting for you to type more. And then it'll type more right at the end. It'll wait, and it's just waiting for you to type more, right? If you do print line, it's actually going to type an enter at the end of what you typed and wait to the next line. Okay, does that make sense? Okay, it's super important. Okay, enter or not enter. Okay. Is everybody good? Does everybody have it? Okay. The next thing that we're going to do is we're going to kind of make a little loop. Okay? So, I deleted all of them but one. I don't care which one you save. And what we're going to do is we're going to make an integer called x. And I'm going to set it equal to 0. Okay, so this right here, this equal sign, this is what we call the assignment operator. It is assigning a value to the variable that we called x. That variable x is of type integer. It can only store whole numbers. It is an integer. It stores whole numbers. The equal sign is our assignment operator, and it says take this 0 on my right and put it into the value of that variable called x. Okay? So, x equals 0. Cool? We got it? Okay. The next thing we're gonna do is we're gonna make a while loop. So we're gonna do while, open parentheses, that variable x is less than 10. I want to print this out. Okay, you see how mine got all like funky looking? It's not indented properly, it looks weird. Okay, trick, Control-Shift-I will indent it for you. Control-Shift-I. Or you can do tools, Control-Shift-I. Auto layout is Control-Shift-I right there. It'll tab it in for you automatically and make it look pretty. It's not just a tab.
Okay.
Okay. Okay, what would happen if I ran my code right now? Anybody? It would say hello world. How many times? An infinite number of times. Okay. I'm gonna run it. Please don't run it. It won't crash your computer. It shouldn't crash your computer, but I can't guarantee that it won't. Okay? I'm gonna run it for you. So basically what we said is we made this variable called x, and we say do this as many times as x is less than 10. We never change the value of x, right? So it's always less than 10. This statement will be true forever, right? Right? Because we're never changing x. It will always be less than 10 because x will always be 0, yes?
Is there a way to make it where each time you put a new hello world, it makes the value increase by 1?
Pause. We're doing that next. Okay, so if I ran it, it's printing hello world forever all in one line, which is terrible, but you see it continuing forever, okay? So, it doesn't let me close it. This is a skill that you need to know. If I come over here, do you see this candy cane thing down here? Okay, this is showing me that I have a program running. Okay, if I want to kill it, I can right-click on that and say reset Java virtual machine. You could also do Control-Shift-R, but that resets it, so now it's dead. It's not running anymore. I killed it. Okay, so Wyatt, what was your idea?
That each time a new hello world gets printed, the value increases by 1.
Yes, so that's a great idea. So what Wyatt said was every time we print out hello world, let's increase the value of x by 1 so that it is changing and eventually will be greater than 10, right? So you can write this a number of ways. We can do x equals x plus 1, or you can do x plus plus, or you can do x plus equals 1. All of those are equivalent to the same thing. Okay, I don't care which one you use. This one is probably the most easy to understand because what it's doing is saying add 1 to x and then assign it back to the value of x. Okay. So this time, instead of printing hello world, I'm going to change this a little bit so we accomplish something. Okay, and so I'm going to print out the value of x is, and then I'm going to do a space because I like things to look pretty. And then I'm going to add x. Do we want to print it on one line or multiple lines?
Several lines.
Several lines, like we don't want it to all go across the screen. It's hard to read. So what should I change?
LN.
So make this print line instead of print. Okay, now let's see what happens. So once you're here, compile it, run it, and see if it does what you think it should do.
Uh-oh.
You programmed before?
Ooh, that's not nice. There's a red dot.
Curly bracket. So that curly bracket goes in that one, that one goes in that one, and you need one to close this one.
That is odd.
So just add a curly bracket after.
Leave it though.
Just type enter and add another curly bracket. You're good, just run it, it worked. Fantastic. Oh, but do you see how it just printed x and not the value of x? Okay, go back to your code. So, not plus x, but this x outside of it. Okay, I see a couple of you where it's printed the value of x is, and it just says x. Like, it doesn't say the value of x, it says the letter x. Okay? So what you need to do is you need to make sure that you close the parentheses, or sorry, the quotes. Close the quotes after is, and then you added x, not in quotes. Because if you type x inside of parentheses, it's just, or inside of the quotes, it's going to print x exactly as it sees it. This is saying print the value of the variable x. It's not in quotes. It's saying print x, the variable. Okay? So make sure that you have that second x outside of the quotes, otherwise it's going to print the letter x and not. Does that work, Andrew? Yep.
Oh!
What do we say that means? That curly bracket goes to that one. That curly bracket goes to that one. You need another curly bracket.
I didn't say that.
So did Jaden. Help Jaden remember.
I was thinking something.
Okay, you guys reached in the final while parsing. What's it mean?
Oh, don't start another curly bracket at the end.
Yeah.
Yeah, that means you're missing a curly bracket to go with.
Just the way you did it.
You didn't add a print line, and then your x's. Make sure you actually have numbers, not just the letter x over and over.
I didn't get it. Almost out.
You don't need all of this.
You read it infinitely, so you know how to kill it.
You got to just show us.
Okay, so here, somebody asked if we, well, somebody in an earlier class said, well, what if I made this while x is greater than 10? What would happen?
It would skip 9 lines. It would skip 10 lines.
Wait, who said that? Okay, why? Yeah, okay, so like, yes, ideally, like, we would think that this might go forever, it might skip, but here's the thing. We don't add anything to x until we get inside the loop, okay? So right here it says x equals 0, and then it comes here and it says, well, is x greater than 10? And what's the answer to that question? No, it's not greater than 10, so it skips to the end of that curly bracket, and then it's done. There's nothing else to do. So nothing would happen.
Yeah, literally.
What if I changed it to while x is greater than 0?
Nothing. Because it's equal to.
Perfect. Okay, good. So you guys are starting to think like programmers. So yes, x equals 0, but x is not greater than 0 because it is 0, right? So nothing would happen. What if I made this greater than or equal to 0?
Oh, you put it equal there.
Yeah, so if we wanted to make it greater than or equal to 0, now what would happen?
Oh!
It would loop forever, and at what point would it end? What? If you stop it yourself, or if it exceeds, hold on, you guys listen to me for like 30 seconds, guys. It would stop either when you stopped it yourself manually, or if it overflowed the size that an integer variable can hold. So if it repeated so many times and incremented it to be so high that the number was too big for an integer variable to hold it. Okay, which probably wouldn't wait that long for your computer to keep running, but it can happen. Okay? What? How many? You can Google it.
Numbers.
I don't know. That makes sense? Okay, so because like we've now learned binary, we now know that there's a finite number of numbers that can be represented within certain number of bits, right? We know that a byte is 8 bits, right? And that holds how many? How high can that number get? 255, right? 0 to 255, so we can represent like 1 byte, okay? And if we ran this, we would see that the number for an integer is already more than that, okay? So we can hold really big numbers. There are lots of bits that go into this to hold our numbers, our variables, okay? You have just a couple minutes left. Tomorrow in class, you're going to be working, just 1 second. Tomorrow in class, you're going to be working your block letter assignment. So you're going to practice printing out letters, making your initials out of tiny little versions of your letters. Okay, and there's lots of hints. This is what we're doing tomorrow. Okay, this is a daily grade, your first daily grade assignment for Java. It's gonna be fine.